Imagine a world where the very ground beneath your feet turns against you, not just from rain, but from a silent, systemic collapse. In 2025, Sumatra faced devastating floods, and while heavy rainfall seemed the culprit, the true villain was far more complex: the failure of its river basin systems, or DAS. This wasn't just a bit of extra water. We're talking about increased sedimentation, choking rivers in Aceh, and massive debris blockages, turning North Sumatra's waterways into dangerous obstacle courses. It's like trying to drain a bathtub with a clogged plug hole, but on a colossal scale. Sumatra is home to short, steep river basins, like the Krueng Aceh and Batang Toru. Think of them as natural water slides, designed for rapid runoff. They are naturally prone to quick water movement, but historically, lush forests provided a natural buffer.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
However, extensive deforestation and unchecked development have systematically dismantled this natural resilience. It's like removing the shock absorbers from a car designed for off-roading. Things are bound to get bumpy. The Batang Toru catchment, for instance, lost a staggering 21% of its forest cover between 1990 and 2022. That's a huge chunk of its natural sponge gone, leading to severe erosion potential. So, how exactly does a river basin collapse? It starts with the loss of infiltration. When forests are cleared, the land can no longer absorb water effectively. Instead of soaking in, rainwater becomes massive surface runoff. This runoff then carries vast amounts of soil into the rivers, causing sedimentation. Rivers become shallower, like a bathtub filling up with mud, drastically reducing their capacity to hold water. It's a recipe for disaster when the next big rain hits. Then there's channelization. Humans, in an attempt to control rivers, often build concrete walls, essentially turning natural waterways into giant, fast-flowing flumes. This actually increases the water's destructive speed, making floods even more violent. And let's not forget the solid debris. Deforestation doesn't just remove trees, it leaves behind logs, branches, and loose soil. When heavy rains come, these materials are swept into rivers, creating blockages. These blockages act like dams, building up immense pressure until they burst, unleashing terrifying walls of water that can sweep away everything in their path. It's a truly destructive chain reaction. Greenpeace analysis confirms significant forest conversion across North Sumatra, Aceh, and West Sumatra. These aren't isolated incidents. They are widespread changes impacting entire regions. The culprit? Often, it's deforestation for palm oil, agriculture, and pulpwood plantations. These activities strip away the natural defenses, leaving the land vulnerable. And when extreme weather events, like tropical cyclone Senya, come knocking, these weakened river basins simply can't cope. The result is tragic loss of life, displacement, and widespread infrastructure damage. But here's a fun, data-driven fact to lighten the mood. A healthy river basin can absorb up to 90% of a flood's energy. That's like having a natural superpower against disasters without needing a cape. Ultimately, the 2025 floods in Sumatra weren't just about rain. They were a stark reminder that the collapsed river basin system was the core tragedy. It's a complex problem, but not an unsolvable one. Addressing this crisis requires integrated strategies, including forest rehabilitation, stricter land use planning, and climate change mitigation. It's about working with nature, not against it. Next time, we'll dive deeper into the specific role of deforestation and its long-term impacts on these vital ecosystems. It's a story that needs to be told. Don't miss out on understanding how we can protect our planet's natural superpowers. Subscribe to learn more and join us in exploring the science behind our world.
There's always more to discover. I'm Selu, and this has been SciCurious, Stay curious, and I'll see you in the next wonder.